Before stars were born, before galaxies spun, before space itself unfurled like a vast, dark canvas, was there anything? It's one of the deepest, most disturbing, and most irresistible questions in all of science and philosophy. If the Big Bang marked the beginning of time and space, then what, if anything, preceded it? For most of human history, we assumed the universe was eternal, without beginning, without end. The sky simply was. But in the 20th century, that idea was shattered by one revelation. The universe is expanding. Rewind that expansion, and everything, space, time, matter, energy, collapses into a single, incomprehensible point, the singularity. A place of infinite density and temperature where the known laws of physics break down. That singularity, according to the standard Big Bang model, is the starting line of reality. But here's the paradox. If time itself began at the Big Bang, then asking what came before is like asking what's north of the North Pole. The question, according to Einstein's relativity, doesn't even make sense. Time did not exist before. There was no before.
And yet, that answer has never satisfied us. Our intuition screams there had to be something, a trigger, a cause, a reason, something that gave rise to this explosion of being.
So scientists, philosophers, and cosmologists have not stopped asking. And what they've found is not one answer, but a multiverse of possibilities, each more mind-bending than the last. Let's begin with the most radical notion. What if there was nothing? Not empty space, not a vacuum, not a cold, silent void, but literally nothing. No time, no space, no dimensions, no quantum fields, just the absence of existence. Some physicists suggest that even nothingness is unstable, that the laws of quantum mechanics allow for quantum fluctuations even in a state of zero energy. Tiny bubbles of existence could spontaneously pop into being, driven not by cause, but by probability. In this view, our universe could have been born from a quantum fluctuation in nothingness, an event that required no cause, no God, no trigger, just chance. But then we run into a deeper mystery. Where did the laws of physics come from? If quantum mechanics made the universe possible, then what existed to enforce quantum mechanics? Can the laws of physics exist without a universe? Or are they merely descriptions of patterns that emerge inside universes like ours? To dodge this infinite regress, some propose the laws of physics are not imposed but inevitable. They exist in the realm of mathematical truth, eternal, and outside time. In this view, the universe emerged because it had to, because it is one of the countless mathematically self-consistent realities that can exist. But now we face another possibility. What if our universe is not the only one? The multiverse hypothesis suggests that our Big Bang was not the beginning of everything, but merely the beginning of our observable universe. Other regions of space may lie beyond our cosmological horizon, forever unreachable, yet just as real. In some versions of inflation theory, the dominant explanation for the Big Bang's rapid expansion, this cosmic inflation never truly stops. Instead, it spawns bubble universes in a vast cosmic foam, each bubble a self-contained universe with its own laws, constants, and dimensions. In this eternal inflation model, the multiverse has no beginning. Universes are constantly birthing from inflating space. Our Big Bang was just the local birth of one bubble, ours. So what existed before the Big Bang? Perhaps an inflating space, or a higher dimensional bulk in which our universe is a membrane, or brane, as described in string theory. According to the ekpyrotic universe model derived from brane cosmology, our universe began when two branes collided in a higher dimensional space. The Big Bang wasn't the origin of space and time, but the violent aftershock of a cosmic collision. These collisions could happen again, potentially forever, in a cyclical cosmos. And speaking of cycles, what if time itself is a loop? The cyclic universe theory proposes that the cosmos undergoes endless cycles of expansion and contraction. big bangs followed by big crunches, rebirth after rebirth. In this model, time never began, it always was. But here's the twist. New research in quantum gravity suggests that even the singularity at the start of the Big Bang may not be real. According to loop quantum cosmology, space-time is not continuous but quantized, made of tiny, discrete loops of energy. Under this model, the Big Bang is not a beginning, but a bounce, a transition from a previous universe that collapsed and rebounded into ours. If true, then before our universe, there was another. And before that, another. Not eternal inflation, but eternal bouncing. The universe never began, it just always existed, changing form. Now let's entertain another idea, one that sidesteps physics entirely.
What if the universe is a simulation?
In the simulation hypothesis, reality as we know it is not fundamental but artificial, a construct running on a computational substrate, like a program on a cosmic computer. In this view, the Big Bang could be the initialization point, the moment the simulation began. What came before? The boot-up sequence, the programming, the mind or minds who created the simulation. This sounds like science fiction, but some philosophers argue it's not only plausible, it might be probable. If advanced civilizations can simulate conscious realities, and if they create many such simulations, then the number of simulated universes might vastly outnumber real ones. Statistically, we might be in one. So what came before our Big Bang? A different level of reality outside the simulation. Something forever unknowable from within. Or perhaps before the Big Bang, there was only potential, a primordial pre-space filled not with matter or energy, but with possibility. Physicist Sean Carroll has suggested that time may be emergent, not fundamental. That our universe may have arisen from a timeless quantum state that had no direction, no cause, no entropy gradient. In this timeless realm, the Big Bang wasn't an event in time, it was the emergence of time itself. In such models, causality is not broken, it's irrelevant. The Big Bang is not a moment in time, but the moment time became possible. Yet even this doesn't fully resolve the mystery. Because no matter how far back we reach, quantum fluctuations, brane collisions, bouncing universes, higher dimensions, we're still left asking, why? Why is there something rather than nothing? Why should anything exist at all? That question lies outside the reach of equations. It belongs as much to philosophy and metaphysics as to cosmology. Some suggest that nothing is simply unstable. Others that something is all that can exist because true nothingness is logically impossible. And some propose that existence requires no explanation, that the universe is a brute fact, irreducible, self-contained, without cause. But others still believe the answer lies beyond science, that before the Big Bang there was something greater, not a force, not a field, but a mind, a consciousness, a creator. This doesn't necessarily imply a god in the traditional sense, but it does suggest that consciousness may be fundamental to reality, not an accident of matter, but a source of it. That before there was time, there was awareness. This idea finds resonance not only in spiritual traditions, but in some interpretations of quantum mechanics, where observation seems to influence reality. Could the universe have emerged not from randomness, but from intention?
It's a possibility, one we may never prove, one we may never fully understand.
But the search continues. We build particle colliders to glimpse the first moments of time. We measure the cosmic microwave background for echoes of the beginning. We map the structure of space to reverse engineer its origin. And yet for all our science, for all our theories, models and equations, we stand on the edge of a mystery so vast it defies containment. So what came before the Big Bang? Here is what we know.
No current model can fully explain it.
The singularity is not a fact but a placeholder, a region where our understanding breaks down. The Big Bang Theory describes the evolution of the universe from a hot, dense state onward, not its true origin. Several competing ideas suggest possibilities: quantum fluctuations in a vacuum, eternal inflation, the ekpyrotic brane collision, cyclic bouncing cosmologies, simulations, timeless quantum fields. Each has strengths, each has challenges, none has been proven. But here is the most crucial truth: science is getting closer. The discovery of gravitational waves, the precision mapping of the cosmic background radiation, and advances in quantum gravity are allowing us to peek further back in time than ever before. One day, we may find evidence that our universe emerged from a prior state, one governed by a deeper theory that unites quantum mechanics and gravity. We may even detect signatures of other universes, fossils of the pre-Big Bang cosmos. Until then, the question remains open, and perhaps that's fitting, because the mystery of the beginning is not a puzzle to be solved, but a horizon to be chased. It reminds us that for all our brilliance, we are still infants in the cosmos. And yet we dare to ask what lies beyond the beginning.
Maybe, just maybe, the answer is not something we'll discover,
but something we'll become ready to understand. Thank you for taking the time to explore the universe with us. We hope this knowledge brings a new light to the way we see life and the cosmos. If you found this video helpful or inspiring, we invite you to share it, leave a comment, and join us on the next journey. Until then, keep asking questions, because curiosity is the beginning of all discovery.